Okay, here we go. I just want to talk a little bit more about perfect squares. Okay, so a perfect square. What do we know about squares? They all have the same sides. From now on, as we move forward, you're going to have to make sure you're looking at your figure. They're going to have lines on it that should be the same if they're going to be the same. Okay, sometimes you could have a picture that looks like this. You could say that those two sides are equal, and then I could go like this with two markings to show that those two opposite sides are equal. All right, but for a square, they're all equal. And so if I know this side is X, how much is this side going to be? X. They're all going to be X because they're all the same. The area of the square is 25. So how much would X be then? X is going to be 5 because we know to find the area of a square, it's side times side. 5 times 5 would give me my 25. So I know that X equals 5. The square root of 25 therefore equals 5. Some people are putting the square root of 5. It's just 5 because X is all the same. They're all going to be the same. I just have to say it's 5. So the square root of 25 is just 5. It's true that the square root of 25 does have 2 5s underneath of it, but the final answer here is 5. What's the square root of 100? It's a perfect square. 10. 10 times 10 is 100. So the square root of 100 is just 10. Okay, do the next couple. What's the negative square root of 16? Exactly, because the square root of 16 is 4, but the negative is being multiplied to the square root, and it needs to be multiplied to my answer as well. How about plus or minus the square root of 144? Almost. Correct. It would be plus or minus 12. 12 times 12 equals 144, and negative 12 times negative 12 also equals that positive 144. Square roots really do have two answers, but in algebra, most of the time you only give the one. Okay, try the next one. What'd you get? The square root of negative 9 equals? Okay, I hear negative 3. Anything else? The other class said 3. I mean, those are really the only options you have, right? What's negative 3 times negative 3? Positive 9. What's 3 times 3? Positive 9. You're never going to get a negative answer because you always have to have a positive times a negative. You have to have one of each. But a square says they have to be the same number. And so the square root of negative 9 is an imaginary number. And again, you're not really going to see this in the homework or anything. I just want to remind you that there is such a thing as imaginary numbers. And if you tell me the answer is 3i, and I give it as a bonus question, I'll give you points. 3i, imaginary. And if you actually tell me the real answer, which would be positive 3 and negative 3i, plus or minus 3i, I'll give you even more bonus points. But that's the last time you're going to hear me say it. I put it on a quiz or a test, and I put it as bonus. You get bonus. Those are imaginary numbers. Look at the difference between B and D. B and D are different. The negative is on the outside, and that's okay on B. But having a negative under the radicand is not okay because you're never going to get a negative answer. Okay, try E. The square root of 48. What do you think? What's the square root of 48? Any guesses? What's wrong? What? What's wrong, Jackson? It's not a perfect square. And that's what we have to finish up today is ones that are not perfect squares. So the technique for guesstimating, estimating would be to find the perfect square before and after 48. Let's list our perfect squares. 1. What's the next one? 4. Keep going. One more. All right, so there's my perfect squares. Those are perfect. 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on, a perfect square. So I'm looking for what's the perfect square before 48, what's the perfect square after 48? What's the perfect square before? So I can see right here, that's where 48 would fit in. So the perfect square before is the square root of 36, and the square root of 49 is the perfect square after 48. Well, I'm going to make a number line right here below it. What's the square root of 36? What's the square root of 49? I have just narrowed it down in time and space between two numbers. The square root of 48 is somewhere between 6 and 7. And I'm going to actually put the halfway mark in here and say 6.5. And then I'm going to think about, is the square root of 48 closer to 36, closer to 49, or closer to the halfway mark? What do you think? Is it closer to the square root of 36, the halfway mark, or the square root of 49? It's right near the 49, isn't it? What comes right before the square root of 49? The square root of 48. Square root of 47, square root of 48, square root of 49. So I know it's right here, right before 7. So I would say the square root of 48 is approximately, because it's an irrational number, it's a decimal that goes to infinity, approximately what's it going to be? What'd you say, Sadie? Who said that? Harley? Somebody whispered something. Good. What was it? It comes right before 7. What's a decimal number right before 7, Aries? Yeah. 6.9 is a pretty good guess. It's right before 7. You can be 1/10 off either way, below it or above it. So if you said 6.8, you'd be okay. If you said 7, I couldn't accept that, because 7 is just 49. I have one more question. How would I know if it was near the halfway mark? What would it look like if it was near the halfway mark? What's the distance from 36 to 48? How far away are they from each other? 36 to 40, and then 8 was going to be 12. They're 12 units away. And 48 and 49 are only 1 unit away. So this is a distance of 12. This has a distance of 1. You're going to know if it's near the halfway mark if these distances are closer to each other, like 4, 5, 6, 7. When you see that, then you know you're near the halfway point, okay? All right, let's look at our number system. And let's review our number system, because today is just correcting the homework from yesterday and finishing 2 problems. And I didn't want to keep moving on until we practice our number system. All right, so I'm looking at the square root of 81. Is it a perfect square or a non-perfect square? It's a perfect square. There's only 2 places it can go. Non-perfect squares are irrational, and perfect squares, the square root of 4 was a perfect square. It belongs over here. So if it's a perfect square, what's the square root of 81? What is it? I'm actually looking for the number 9 then. I'm not looking for the square root of 81. I'm looking for what it equals. It equals 9. Is 9 in the whole numbers? If I look in the whole numbers right here, is 9 in the whole numbers? It is. 0, 1, 2, 3, 4, 5, all the way to infinity. So it's in the whole numbers. Is 9 going to be in the integers? Yes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to infinity. It's going to infinity on that one as well. How about the rationals? Is 9 in the rationals? Hey, I'm putting it in the wrong box. Thank you. I appreciate your kindness. All right, integers. And then is 9 in the rational numbers? Yes, because it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to infinity, and fractions and decimals, but 9 is in there. Be careful about irrational, rational. This time rational is over here. Remember that you can't be irrational and irrational at the same time. You can't be both of these. You're either rational or irrational. And is it in the real numbers? Yes. Okay, I got a little trick for you. Ready? These are always going to be all real numbers. That's the real number system you are working on. They're always all real. I would not give you anything that wasn't real. So the trick here is to find out where it started. It started in the whole numbers. Look how the boxes are nestled within each other. That's because whole numbers are in the integers, and whole numbers and integers are in the rationals. So I found it started right here. That means it's going all the way up through whole, integers, rationals to the real. Every time you find where it starts, and it's always going to continue upwards. All right, how about the number 8? Where's the first place I see the number 8? I see them where? In the whole numbers. They are in the whole numbers, my positive numbers, yes. So what's it going to do? It's going to continue all the way up. 8 is also in the integers. 8 is in the rationals, and they're all real numbers. How about the negative square root of 100? Is it a perfect square, Adrian, or a non-perfect square? Is the square root of 100 a perfect square or a non-perfect square? It's a perfect square. James, what's the square root of 100? But what am I really going to write down? I'm going to write down negative 10. I got to keep that negative sign in front of the 100. Where's the first place you see a negative number? The first place would be in the integers, negative, 0, and positive. So it starts in the integers, and it's going to work its way up into rational numbers that also have negatives and up to the real numbers. So once you find where it starts, it works its way up. How about negative 4.8? Where's the first place you would see negative 4.8? Rational. I see a negative sign. Doesn't it start in the integers? There you go. There are no decimals in the integers. I need a negative and a decimal, and the first place you're going to see that is going to be in the rationals, negative and decimals. So it's in the rationals, and they're all real. All right, not very many people did this correctly in the homework. There might have been 1 or 2. You are going to be ordering these numbers from least to greatest. And I wrote on just about every paper, use the original numbers. Okay, now you're going to start having points taken off if you don't use the original numbers. What's the smallest number that we see here? Exactly, negative 10 is the smallest, but I need to write down negative square root of 100. What's the next smallest number? Negative 4.8, and then 8, and finally, the square root of 81. We're ordering those real numbers, not the ones that we used and manipulated to figure out some things.